Hello! For today's lesson, we're going to talk about a concept called flow-weighted mean concentrations. Flow-weighted mean concentrations. Flow-weighted mean concentrations came about because sometimes in water science, when we have a set of concentrations, just taking a straight, regular statistical mean or median doesn't represent those concentrations very well. And so we had this concept of flow-weighted mean concentration. In this hypothetical data set that I made up, I have water samples that were collected Monday through Friday, so 5 consecutive days, and we have nitrate concentrations for those 5 days. In this hypothetical data set, what happened was that on Wednesday night into Thursday, say for example, the farmer happened to apply nitrogen fertilizer, and so you'll see those nitrate concentrations increased a lot from Monday, Tuesday, Wednesday up to the values on Thursday, Friday. So if I was to take a straight mean or regular statistical average of these data, I get 9.4. If I was to do a median of these data, I get 5.2. I'm not really sure how well either of those numbers reflect the data set, especially when you look at column D and you see the differences in flow volume. The day with by far the most flow happened to be Thursday. So pretend, for example, the farmer applied nitrogen Wednesday night into Thursday, and then it rained a lot on Thursday. And so we happen to have the most flow volume occurring on Thursday, with also a fair amount of flow volume occurring on Friday, the amount of water leaving that tile outlet. So how do we calculate a flow-weighted mean concentration, which takes into consideration the amount of water that also went through the pipe? First step we do, total cumulative flow, and this is in liters. Calculate total cumulative flow. This is easy. Equals sum. We just sum up all of our flow. 705,000 liters. Next step, percentage of flow. And this is just a percent. So this is also an easy formula. You want to do 100,000 divided by my total. Now this formula, as I've entered, is not the right formula. To make it easy, I'm going to hit the F4 key. F4 is the magic button that locks that bottom number in place, so that now when I drag this formula, it continues to refer to the right bottom cell or the right denominator. Okay, next step equals the percentage of flow times my concentration. So again, nothing simple, it's just algebra. We multiply the percentage of flow for this time period by the concentration, and then I want to do equals a sum of all of these, and this is my flow weighted mean concentration for this given time period. Now compare that number with my mean and median calculated before. The median, sure, that's a good median for that range of numbers, but when I'm looking at how much water actually left that tile pipe, even 9.4 seems low. It's not a really reflective value of the concentrations occurring at the most flow. And so in terms of flow-weighted mean concentration, that ends up being a much more reflective value for the concentration and the flow considered together.